Good morning, sir.
Good morning or good evening?
Yeah, good evening.
Good evening. Yes, Ramiz and Paiga, how are you guys doing?
I'm fine.
Good, sir.
Good. All right, so let's continue. By the way, Ramiz, welcome to the batch.
Yeah.
And in the batch right now, the same chapter, pressure and force and pressure is going on, for which you had in your demo class, in your first demo class, we were doing the same chapter, right? So the
Yeah.
first topic in the batch, that is force, is completed. Right now we were doing the pressure. Okay, now?
Yeah, that's fine.
Okay, now? So we are going to continue from here. Aisha and Ibrahim are not here right now, no? Okay, anyways. By the way, Vaiga, the previous class which we had, assignment were given to you. Did you completed that or not, Vaiga? The chapter synthetic fiber and plastics.
No, sir.
You haven't? Also health now better? Or?
Yes, sir. It's far more better right now.
Good. All right. You guys turn your cameras on and let's start the class. Talking about pressure. In the previous classes, we have learned about pressure. That pressure is basically force acting upon a unit area. Right? We also learned about the on what factors pressure depends. So the first thing, it will be depending upon the area in contact. Right now. So the pressure applied on object will depend upon the force applied and the area over which the force is applied. For example, the same force applied to an object will produce different amount of pressure depending upon the area over which it acts. So you say that you have two objects, object A and object B. And here you have this object and here you have this object. Now the surface area in contact is different for these two objects. This is smaller, but it is more in the next case. Say you are applying a same force of 10 Newton on both these objects. Let us say you're hammering these nails. One is sharp, another one is blunt. So thereby the pressure that will be generated, although the magnitude of force is same, but the pressure generated will be more in the first case, but it will be less in the second case, right? So this is one of the factor that depends. So the pressure depends upon the area plus force also. Now take another case here that we are taking the same nail with the same area, but now we are hitting it, we are hammering it with a magnitude of, let us say, 30 Newton. So thereby pressure will be maximum more in this one now. Pressure will be more in this one. So pressure, as we know, it's basically force acting upon a unit area. It will depend upon the factors like force determines the pressure. Higher the force, higher will be the pressure. Then area also determines the pressure. Lesser the area, more will be the force. More the area, lesser will be the, lesser will be the pressure. Lesser the area, more will be the pressure. Got this thing, guys?
Yes,
Yeah.
sir.
Talking about pressure in fluid, right? So fluid pressure is basically the force per unit area on a surface or in a fluid, right now? Okay, so we learned that the pressure exerted by a fluid like gas or liquid in a container is transmitted undiminished in all directions on the walls of the container. Basically what we know that the molecules of the fluid like gases or liquids, they are in continuous movement. Although we know that the molecules of the solid objects are tightly fixed, so thereby they have no space to move into. So the molecules of the solid object does not show any movement. That's why solids do not flow like air or water. They do not flow. But air and water, it can flow from one place to another because the molecules show some movement. As we learned in the previous classes, like these are the molecules of the water. See that these are the molecules of the water. So due to them being in movement, so they will be hitting the wall of the container in which they are kept, right? Viger, Ramiz.
Yeah.
Yes, sir.
Okay. Na? Also, they will be moving not only in one direction, but they will be moving in all the direction. Okay. Na? So they might move in this direction, in this direction, in this direction. So in all the direction, they will be moving. Okay. That is one thing. So here we learned that on a given unit area, let us say that this is a very small unit area on which the molecules are hitting. Molecules of water are hitting on this small unit area, and it will be hitting it with some force. All these molecules will be hitting the wall of the container with some force. And what we know that force acting upon a unit area is called as pressure. Right, Vaika and Ramesh? Yeah.
Yeah.
Okay.
Yes, sir.
Now there are so many molecules in this one, not just one or two. In fact, uncountable number of molecules will be present in it right now. So all of them
Yes,
would be applying force on the walls of the container, and thereby all of them would be generating pressure on it, on the wall of the container. So due to the collision of the molecules on the container, wall of the container, pressure is generated here. That is one thing which we have learned. Yes, Aisha, how are you?
Fine, sir. Alhamdulillah. How are you, sir?
Yes, I'm also good. Okay. By the way, Aisha, I will be providing some questions to you in the chat box. Okay, now, and you will be required to do that as well. Because right now, I think you should be focusing on your exam. I mean, like this chapter force and pressure, this is not in your syllabus, right?
Yes, sir.
So thereby, I'd be giving some questions to you in the class. So you'd like to do the questions or just continue with this chapter? You tell me.
I would like to do the questions.
Questions now? Okay, okay. I will be providing in a while, okay? Meanwhile, try to pay attention here as well until I haven't provided the question until, okay? So the first thing we have learned in the case of the pressure in the fluid, that the molecules of the fluid here will be exerting it will exert some force on the wall of the container in which it will be kept. It is not only true with the case of water, but the molecules of the gases will also be doing the same thing. Okay, that's why we see that when the LPG cylinders, when it explodes now, too much of pressure is released, right? Because the liquefied petroleum gases have been pressurized, it has been kept under, it is stored under it with high pressure, and actually all of them are continuously hitting the hitting the walls of the container. Also interestingly, when it is stored inside the cylinder, it is in the liquid state, right guys? Liquefied petroleum gas, the definition itself tells it, the full form itself defines it, that it's liquefied petroleum gas. The gas has been liquefied. So when we increase the pressure of the gases, it is converted into the liquid, which we'll be learning in a minute. Okay. Nonetheless, in the case of this water, we have learned the first thing, that the molecules of the water will be continuously hitting the walls of the container with some force, and the force are acting on a unit area, thereby pressure is generated. Now, furthermore, when we look at when we look at this jet, so the water jet that is coming from the bottom hole, it is having maximum pressure in it. So that tells us that with the increase in the depth in the fluid, the pressure increases. Okay, now as the depth increases, thereby the pressure increases. That is one thing. Also, we know that at any given height in the liquid now, like for example, at this height, the pressure exerted at this height by all the molecules would be similar. This one here. Try to understand. All these molecules, like I have mentioned 4 molecules of water here. All of them are at the same height, right, Aisha, Vaika, and Ramiz?
Yeah.
So all of them will be having same amount of energy. So they will be hitting the wall of the container with same force. Okay, now they're going to hit the wall of the container with the same force. Okay, now so thereby pressure generated by them will also be same. Okay, but when we go down, when the depth increases, the pressure will increase. Hope this much should be clear. So the pressure in the fluid is determined by what factors? Pressure in this liquid particularly is determined by the depth, first of all, right? That is one thing. Furthermore, it is determined by the density of the liquid also. Okay. So in the case of the fluid, especially we are taking the case of this liquid here, talking about liquids. So the factors that determines the pressure are as follows. The factor that determines the pressure are as follows. The first thing is the depth of liquid. So as the depth increases, the pressure also increases. As the depth increases, the pressure also increases. That is one thing. Next thing is the density. Next thing is the density. So denser fluids, like for example, we take the if you were to take the case of let's say oil, or let us take the example of honey, for example. In the same container, if I have stored honey and I have made similar holes in this in that jar also, will honey also be coming out via these holes with the same speed, with the same force?
No.
No, because honey is more denser. Its density is more. Getting it now, Vaika, Ramiz, and Aisha.
Yeah.
Okay, no?
Yes, sir.
Ramiz, you getting it or not?
Yeah, I'm getting it.
Huh. So liquids with high density shows less pressure. Shows less pressure. So density is also one of the factor that will be defining it. Okay, no? Okay. Furthermore, another property is viscosity. Viscosity. We can take the same example of honey to understand this. Honey and water. Viscosity is basically defined as it's a property of the resistance to flow. It's a property of the fluids whereby where they will be resisting its flow. Getting it what I'm trying to say? For example, you can understand in this manner. Take some honey and take some water. Take some honey and take some water and throw it on the ground, or just allow it to just pour it on the ground. Okay, now what will you observe? That the water will spread over a large area, while the honey will spread to only a small area, isn't it? So say that this
Yeah.
is honey, and honey will be spreading only to a small area if I were to pour it from a bottle of honey. Okay. But what I see here, in the case of water, the water will be spreading to a large area. Large area. So actually the thing is that it resists its flow. Honey will be resisting the flow. So it resists more. It resists more. While here it resists less. Okay, now? So here talking about viscosity, viscosity is basically the resistance of a fluid like a liquid or gas to change its shape or to move from one place to another. Getting it? It's not only the property of the liquid, like I have only given the example of liquid here, but it's taken in context of gases also. So viscosity is the property of resistance of the fluid. It's the resistance of the fluid to change its shape or to restrict its movement. You guys know about friction, right?
Yeah.
Okay, now. So there will be more friction in the case of honey. Water, in the case of water, there will be less friction. Okay, now. Is that thing clear to everyone?
Yes.
Okay, now.
Yes, sir.
So here, liquid or fluid basically, liquid or fluid with higher viscosity have less pressure in it, have less pressure. Is that thing clear? And vice versa. Liquids with low
Yes, sir.
viscosity have high pressure in them. Okay, so they are inversely proportional. So in short, viscosity basically means opposition to flow. Opposition to flow. So these are the factors that determines the pressure, depth, density, and viscosity. Other factors that will determine will be the pressure. I mean to say will be the temperature also. Okay, now will be the temperature. Now take the same example. Let us say we have taken a honey which is cold and take a hot honey. Okay, na? We have warmed the honey. Now the warm honey will be flowing more. Try to understand this. Warm honey, it will offer less resistance to flow. While the cold honey, it will be offering more resistance. While the warm honey will be offering less resistance to flow. Getting what I'm trying to say? Yes. So temperature also determines the pressure in fluid. Temperature also determines the pressure. Okay. So higher the temperature, higher the temperature, lower will be the pressure.
Sure.
Temperature is inversely proportional to pressure. Got this thing? Sorry, directly proportional to pressure. Okay, na? Directly proportional to pressure. So higher the pressure, higher the temperature, higher will be the pressure. Okay, how can you understand this? Let me tell you. Talking in the context of temperature. Say you have taken a closed container in which you have taken cold water. And now you are heating the container. You have taken another container in which you have taken the water, but you are heating it. Okay, you are going to heat it. So here, the molecules of the water will be energized. It will be energized, isn't it? The molecules of the water will be energized. Say that this container is basically a pressure cooker here. This container is a pressure cooker, all right now, and we are heating it. We are heating it. So thereby, what happens? The molecules of the water gets energized, and it will be hitting the wall of the pressure cooker with more force. Right? And they will be hitting the wall of the pressure cooker with more force, so thereby more pressure will be generated. So here temperature is directly influencing the pressure, isn't it, guys?
Yeah.
So what happens if the nozzle of the pressure cooker does not work properly? It ultimately explodes now. Isn't it, Vaiga,
Yes.
Aisha? You guys might have heard of the cases where a faulty pressure
Yes,
cooker
sir.
explodes, and in fact, it can lead to the death of the person as well. So one should be careful around this, and if it is not proper, then one should be replacing it. Okay. While in the case of the cold water, let's say I'm not heating this. Okay, no, sorry. The sign of this shouldn't be here. I'm not heating this. So thereby, there will be any pressure? No. The nozzle will the water vapor be coming out of the nozzle?
No.
No. So here temperature also determines the pressure. Higher the temperature, higher will be the pressure. So another factor, let me just write it over here. That was the temperature. Okay. So that was the case of it. Furthermore, we have some activity from the NCERT. This activity number 11.8 basically says that you have taken two thin transparent plastic tubes and you have filled the water in them. By the way, on the other hand, you have taken a sheet of balloon or sheet of rubber which you have tied to it. So here the water which is having more amount of water, so the bulging in the rubber balloon is more. Right now? Getting it now?
Yes, sir.
So here the height of the water in this is less while the height of the water in this is more now basically. So the pressure depends upon the height of the water. Pressure depends upon the height of the water. Let us say that you have taken two vessels. Like for example, you have taken a vessel like this and you have taken a vessel like this. Okay, now, and in both of them you have poured equal amount of water. Let us say you have poured 100 ml of water. 100 ml of water you have poured in both of them. This one and this one. In which one the pressure generated at the bottom will be more?
The tube.
The first one, no?
Yeah.
Yes, Aisha, Vaiga.
Yes, sir.
So here more
Yes.
pressure is generated because of the height here. Because of the height, or we can say depth. The depth or the height of the water is more here, thereby the pressure generated at the bottom is more. Okay, and that is one thing. Furthermore, this activity was also to basically show that the liquid. This was the activity to show that the liquid exerts pressure on the wall of the container. Getting it now? So thereby, like we have taken this taken this bottle and we have connected a pipe to this. Okay, now this seal, by the way, it was written by me, so it is not there in the diagram. Okay. So we have taken an empty bottle, we have filled it with water, and we have connected a pipe to this. And on the other end of the pipe, we have connected a balloon. So what we get to see that to prove that the molecules of the liquid will be exerting force on the wall of the container, we see that as the liquid will go into this rubber sheet now, into this rubber balloon, so the balloon also starts to expand. So what does this says? It says to us that the molecules of the water must be hitting the wall of the container, must be applying some force on the wall of the container. That's why when it goes into this also, there also the molecules, it starts the size of the balloon starts to explode. Like this is the balloon, the molecules of the water must be hitting the wall of the rubber balloon. That's why it starts to expand now. Getting it now?
Yeah.
So these are the activities there that is given there in the answer. Furthermore, as I said in the beginning, as we learned about few of the properties, that at the same depth or same height, liquid exerts equal amount of pressure now, right? So we have taken another bottle here and we have made holes in it at the same depth. Okay, now let us say at a depth of 5 centimeter we have, or 2 centimeter we have made holes in it. Okay. Now observe the jet of the water. Observe the speed of the water coming out of it. All of them are at same speed now, isn't it? So this activity proves that liquid exerts equal pressure at the same depth, right? And now if you were to make the holes at this depth, like this, so thereby the liquid there also it will be coming at the same speed like this. Is this thing clear to everyone?
Yes, sir.
Yes.
Okay. Meanwhile, let me just provide some questions to Aisha. I will be continuing in a minute. Okay, now. Okay, Aisha, you tell me from which chapter you would like to do questions.
Microorganism, friends and foe.
Okay, microorganism, friends and so. Okay, okay. Just give me a minute. I will be providing some questions to you. Okay, now. Meanwhile, you guys read this paragraph. Yes, Aisha, I have provided some questions to you. Okay, now. Try to do these questions. I will be providing some multiple choice questions to you as well. Okay, now. You
Okay,
have
sir.
to answer them in short. Okay, now these are short answer questions. Okay. So we did learn about liquid, which is one of the fluid. Another fluid is this gas. Gas will also be exert, the molecules of the gas will also exert the pressure on the walls of the container in which they will be kept. Furthermore, the molecules of the gas have higher kinetic energy in them. Anything that is moving is having a kinetic energy. Okay, now anything that you see moving around you is said to be having a kinetic energy. If I am running at that time, I am having kinetic energy. Okay, now. So there, so we get to see that the molecules of the gases have more energy as compared to the molecules of the liquid. Getting it, guys? So thereby they will be applying more pressure, more force on the wall of the container. They will be hitting the wall of the container with more force, isn't it, guys? So they hit the wall of the container with more force on the given unit area. So thereby they will be generating more pressure, isn't it? Okay, now because we know that
Yes, sir.
pressure depends upon force also. That is one thing. Okay. Furthermore, talking about the pressure exerted by the gas or basically atmospheric pressure, it will depend upon several factors. Okay, now just like we have learned in the case of the liquid, that force will determine, okay, now the pressure there. So the factors that will determine the pressure exerted by the gases are as follows. Can you guys think of it? I want to know like what you guys think. Hmm? Which factors will determine the pressure exerted by a gas? Yeah. Factors that determines the pressure exerted by gas.
Sir, the temperature.
Yeah, the temperature, of course. The temperature. Okay, we'll be taking
So
up that as the third point or fourth point. Yeah.
the
Vaika.
increase in the altitude decreases the pressure.
Very good. Temperature or basically height or altitude, right?
Yes, sir.
Height and altitude. Very good. And what else? Mhm. What else you guys think? There are a few other factors also. There are a few other factors like the number of molecules or the number of gas particles in a given container, or that we can basically refer to volume, right? Now,
Sir,
yes,
smaller the container, the more the pressure.
exactly. Smaller the container, more will be the pressure. Okay, now
Okay.
getting it now. So if
Yeah.
you have stored the molecules of gases in a small container, so thereby the pressure exerted by it will be more, right now. But if it is stored in the bigger container, the pressure generated will by it will be less. So volume of the container in which the gas will be stored. Got this now. That is one thing. Furthermore, the volume of the gas also will determine. For example, the amount of the gas in this container, if it is doubled, then what will happen? The pressure inside this will also get doubled. Okay, now. So thereby, another thing is the volume of the gas in it. Volume of the gas. So if the volume of the gas, let's say in this container has been doubled, so thereby the pressure inside the container will also double. Or if you were to cut the volume of the gas in half, reduce the volume of the gas by half, the pressure will also decrease in that case. Getting it, guys, everyone? So this is the thing here. These are the factors that will determine the pressure exerted by the gas. Any confusions in this? Please let me know.
No.
Okay, no? Hope you guys are getting it. Also, the more the pressure, more the force with which the gas molecules will be hitting, more will be the pressure generated here. Okay, no? That is one thing. Now let us understand about atmospheric pressure. Okay, no? Vaiga, you have any questions from previous topics? And
No,
Ramiz,
sir.
well, Aisha, you're
No,
solving this
sir.
question. Okay, Aisha, you're facing any difficulty in solving the questions? I have given very basic questions like what are microorganisms, what are the different types of microorganisms, what are bacteria, give an example of bacteria, what's the difference between useful and and harmful microorganisms. Okay. Okay, talking about atmospheric pressure, we know that there's a layer of the gas that is covering the surface of the earth, and that layer of a layer of gas or a blanket of gas that is surrounding the earth's surface that we know as atmosphere. And the air present in the atmosphere will be exerting a pressure on the earth, which will be called as atmospheric pressure. Okay, now, so suppose we have taken a column of air here, we have taken this column of air here. Okay, now, and all the molecules present in this column of the atmosphere or column of the air, say that all these are the molecules present in it. All these are the molecules present in it. So all of them will be applying some pressure on the on this given unit area. All these are the molecules of the air, and we know that air has got different gas particles in it. Now, what is the composition of the atmosphere? We have different kind of gases like nitrogen is there, oxygen is there, carbon dioxide is there, neon, argon, plus water vapor is also there. Okay, now so these are the different molecules, different gas molecules present in the atmosphere, and all of them will be having some energy. They have kinetic energy, so they will be applying. They will be hitting this unit area with some force, and thereby they will apply some pressure on it. Okay, now also we know that these molecules of these different gases will have some weight. So with the virtue of their weight also, they will be applying a pressure, because in something that has weight will apply pressure. Getting it, guys?
Yes,
Is
sir.
that thing clear to everyone? Okay. So as the depth will increase, or as the altitude, I mean to say, as we go closer towards the surface of the earth, so the density of the molecules actually increases. The density of the molecule increases. So in the higher altitude, there are less air molecules. Okay, now, but when we go close to the surface of the earth, the number of air molecules increases. So thereby the pressure will increase here. Okay, now, because in this, what I say, that volume of the gas will also determine the pressure generated by the gas here. If there's more amount of gas molecules, the pressure will be more. Okay, now, there's more number of gas molecules, the pressure will be more. As you go higher up, there are less number of gas molecules, so thereby the pressure will be less. Is that thing clear to both, to all of you?
Yes, sir.
Yes, sir.
Furthermore, pressure, we know that we measure it in the unit Pascal. Okay, now it is measured in the Pascal. Okay, by the way, you guys understand about this now, like what is sea level? You guys understand about sea level or not?
A bit.
Okay, what do you understand by? Yes. Viger?
I'm not sure about sea level, but is it like the distance from the sea to land?
No, that's not what sea level is. It's the basically, it's kind of a average or base level for measuring the elevation or measuring the depth on the earth. For example, if I were to measure the height of the Mount Everest, or if I want to measure the depth of the Mariana Trench, you guys know the Mariana Trench is the deepest point on earth, right now?
Yeah.
So I must take a base from where I have to measure. For example, on a ruler, you start measuring from here, 0, 1, 2, 3. So you have to take a base here. 0 is taken as the base point from where you start measuring. Getting it or not?
Yes, sir.
So sea level is the base level for measuring the altitude or the depth on the Earth's surface. Getting it, guys? So that is what sea level is. Hope it should be clear. Okay.
Yes, sir.
We just let me make a small drawing for it to give a clarity. Okay, now, like say for example, this is a ocean. This is let's say ocean. And let us say that this is a this is, let's say, a cliff, something like that. 0 meter, 100 meter, 200 meter, and so on. Okay, so this is above the water. Under the water, there also will be taking the reading. So we'll be taking the reading in minus 100 meter, minus 200 meter, minus 300 meter, and so on, like this. Okay, now, so here we have taken a base value of 0 meter. We have taken a base value of 0 meter, and that will be the sea level. Okay, now that will be the sea level. Okay, so sea level is basically the base level, or basically the average level, base level which we will be using for measuring the altitude or depth on Earth's surface. Okay. Also, the sea level has been rising because of the global warming. As the global warming is increasing, so thereby the surface, the elevation of the oceans are increasing because of flooding, because of the melting of polar ice caps and glaciers. So sea level has now been rising. Got this, everyone?
Yes, sir.
Yes, sir.
So the value of the atmospheric pressure at sea level is about this much, 1,1325 Pascal. Okay, now. Also, you guys think where on Earth atmospheric pressure will be maximum? Where on Earth atmospheric pressure will be maximum and where it will be lowest? Think of this. In fact, we have discussed it just right now. You know, atmospheric pressure is highest at the sea level actually, because the depth of the atmospheric because of the depth of the atmosphere is maximum there. So thereby the weight of the air column above the ground will be exerting more pressure on the ground here. Okay, now, so thereby the atmospheric pressure is greatest at sea level. Getting it what I'm trying to say? Like atmospheric pressure is
Yes.
not going to act under the ocean now. It will be not occurring like the air molecules ends here now. Air molecules will be ending here. These are the air molecules. Okay, now. So take this, like for example, say that this is the Mount Everest, having a height of 8,848 meter. This is the Mount Everest, let us say. So when you go to the Mount Everest, let's say you are here on the Mount Everest. So the pressure will be least here. Is the highest point on Earth. So the pressure here will be very less. But when you are at the 0 meter, when you are at the sea level here, so maximum number of air molecules are concentrated here. So thereby the pressure should be maximum here, isn't it, guys?
Yes, sir.
Okay, now. Okay. Furthermore, the atmospheric pressure keeps on increasing as you move towards the Earth's surface. Like as you will be coming down from the Mount Everest towards the Earth's surface, the atmospheric pressure will keep on increasing. Okay. Because answer, where on Earth atmospheric pressure is least?
On the highest point of the Earth.
Basically on the highest point of the
Earth.
like at the top of the Mount Everest. The air pressure will be minimum there. Okay, now.
Okay.
That is one thing. Okay. Also, there are some natural phenomena like in cyclone. Okay, now. So in the middle of the cyclone, the pressure will be very, very less. You guys would have learned about how cyclones are formed. The middle zone of the cyclone is a zone of very low pressure. Okay, now. Anyways. Furthermore, here it says that the weight of air in a column of height of atmosphere and area 10 by 10 centimeter is 1000 kilogram. This is roughly same as the area of our head. So that means that you have about 1000 kilogram of air on your head. The question is then, if this much of weight of air is above my head, then why does my head not explode? You guys understood what I'm trying to say here?
Yes, sir.
Yes, sir.
So say that this is an area of 10 by 10. This is an area of 10 by 10. 10 is the height, 10 is the breadth, 10 is the length. Okay. And say that this is the head of any given person, for example. So the head of this person is actually experiencing a weight of how much? About 1000 kilogram. So this much of area, this much of volume of air above my head, if I am on the surface of the earth, I'm not in a way on a Mount Everest or like on other high point. So the weight of the air above my head is about 1000 kilogram. So just think about this. So why does our head does not explode? The thing here is that the amount of atmospheric pressure upon is quite large due to the large surface area of the atmosphere around the earth, but we do not experience any of its effect. What could be the reason behind this? You guys ever thought about this? Think for a while. You guys would have learned that lot of metabolic activity goes in our body, blood circulation goes in our
Blood
body,
pressure.
blood pressure. Okay, now. So although the weight of the air on our head, on our body is very much, but our body does not explode. Our body does not explode because of some of the reasons, like we get to see that all these forces that are acting on our body, it is not concentrated at just one point, but this is acting from all the directions. Okay, now the weight, I mean to say the pressure is acting from this direction, from this, from this, from this. So it is acting from all the directions almost equally. That is one thing. Our body also generates pressure, like due to the flow of the blood, pressure is generated, isn't it, guys? So the blood pressure is generated due to the moving of the blood through the blood vessels, right? Now, that
Yeah.
is one thing. So this is one of the reason why our body does not explode, because kind of pressure is balanced here. Okay, now the pressure is exerted by the flow of our blood or the atmospheric pressure. They balances out each other. Thereby, we do not. Our body does not explode. But what if you were to go to a Mount Everest or any high cliff or a mountainous region? So sometimes at higher altitudes where the atmospheric pressure is low as compared to that at the Earth's surface, or at the lower altitudes, nose bleeding occurs. So what could be the reason for this? Yes.
Sir, the body doesn't have enough time to adapt to the atmospheric change.
Okay, like our body takes some time to acclimatize.
So since our body has like can't adapt to the change that quickly, our nose starts bleeding due to the low amount of pressure.
Okay, that is the case. Like the people that are already living in the mountainous regions, so their body have acclimatized. Okay, now, so thereby they don't feel this problem. But if I, as a tourist, were to go on a Mount Everest, or as an explorer, if I were to go there, I might experience nose bleeding. But if I were to stay there for 1 week, for 2 weeks, or for a month, then I will no longer be experiencing that problem because our body adjusts itself.
Yes, sir.
Getting it, guys. Okay. Also, you guys know that the flow of blood in mountainous people is more. Okay, now the rate at which the blood flows in the mountainous people is more. Also, people that are living in the higher altitudes have more red blood cells in their blood than the people that are living in the lower altitude areas. Getting it now? Like if you were to check the blood of a mountainous person, he will be having more red blood cells. Why is it so? Because we know that the red blood cells, the RBCs. Also, one more thing, we know that in the mountainous region, the air is thin. So thereby the availability of oxygen is also low. Keep that thing in mind. So the reason why mountainous people, they have more red blood cells. We know that red blood cells have hemoglobin in them. What's the function of hemoglobin? It carries
Oxygen.
oxygen. So since the availability of oxygen is less in the higher altitude area, so thereby having more number of red blood cells will ensure that the body gets adequate supply of oxygen. Getting it now? If there are more number of red blood cells, more amount of oxygen will be binded with hemoglobin, and hence the person, he or she will be getting more sufficient amount of oxygen. Is that thing clear to everyone?
Yes.
Okay, now. Now talking about the nose bleeding, why it occurs. Okay, now. So the thing is that blood pressure, due to the flow of the blood, due to the blood flow, blood pressure is generated. All right. And we have the atmospheric pressure also. Atmospheric pressure is also there. Now here in this situation, the pressure inside the body is more as compared to the atmospheric pressure. The pressure you inside the body is more than the atmospheric pressure. And we know that movement of anything takes place from a region of higher pressure to a low pressure. Your body has high blood pressure. The pressure generated in your body is more, while the atmosphere as compared to your body will be less, will be having a less pressure. And this occurs only when you will be going to a mountainous region. a place of very high altitude. So thereby the nose blooding occurs. The blood flows out of the nose because of the pressure difference. But when you are on a lower altitude, the pressure is balanced out. Okay, now. Okay, so that is about that is when you'll be going in higher altitude. But what about when you'll be going in under the oceans? So thereby you have seen that swimmers or the divers will have to wear special swimsuits. They have to wear special swimsuits when they will be going deep inside the sea, and the suits actually protects them from the sea pressure. Without the help of the sea pressure, if they were to go there, their body will not be able to tolerate the sea pressure, and their body will basically be crushed due to the sea pressure. Getting it, guys?
Yes, sir.
Also, have a look at this image here. As the altitude is increasing, you can notice one thing, that the number of air molecule is decreasing, because of which what we see that the pressure here is less. Remember what I said in the beginning, that if the amount of, or if the volume or amount of gas molecule is less, pressure will be less. If the number of the gas molecule is more, so thereby the pressure will be more. So the reason why at the lower altitude the atmospheric pressure is high, because there is more number of gas molecules at lower altitude, so thereby more pressure is generated. So just think of this, that there are so many air molecules here, and all of them will be hitting the, I mean to say, all of them would be applying the pressure on this area. So thereby more pressure is generated here. But since there are less number of air molecules here, so thereby the pressure generated by them is more.
Yes, sir.
Okay, now. So that is the reason why there is a difference in pressure. So this person will be more likely to suffer from nose bleeding. Okay, but if it starts to live there for some time, so his body will acclimatize. It will not adapt, but will acclimatize. Acclimatization and adaptation, they are two different things. Okay, now.
Okay, sir.
Acclimatization and adaptation are two different things. Meaning that, for example, adaptation is what, like, and when an organism will be developing some changes in their body, some special changes, or like a new organ or new tissue is formed in their body, that will be called as adaptation. So there's a thin difference between adaptation and acclimatization. Okay, now.
Okay.
So adaptation is like a long-term and a permanent change. It will be long-term and a permanent change, and that will pass from one generation to another. Getting it now? It will pass from one generation to another. Like for example, some of the insects or some of the animals might change their color, or like they can be hyperpigmentation in them that will allow them to hide from the predators. For example, some of the insects, they will change their color in order to hide themselves from their predators, and they will be passing on that change to their offsprings, and that's a permanent change. It will keep on passing generation after generation. It could be any other changes also. Getting it, guys?
Yes, sir.
So adaptation, it's a long term, and it's a kind of a evolutionary change that will evolve, that will be evolving in a long span of time. Okay, no? And that could be to adjust in the environment due to some changes. Okay, but acclimatization, it's a short term change. It's a short term change, and it will not be passing on from generation to generation. It doesn't mean that if someone were to went to a mountainous region and live there for a month and then come back, it doesn't mean that the red blood cells in the body that would have increased in his or her body for a momentary period of time, for a short duration of time, it doesn't mean that this thing will pass on to his children or to her children. Getting it now? So whatever changes the body would have made, it would have made to survive for a short period of time. So that will be a temporary change, and it can be reversed. So there's a difference between adaptation and acclimatization. Hope you guys have understood this. Okay, now.
Yes, sir.
Why are you getting it, Aisha? Okay, Aisha is
Yes, I
answering the
got.
questions. Yeah. Okay. Then we have this instrument called as barometer. So barometer is a scientific instrument that will be used in the field of meteorology to measure the atmospheric pressure. How much of pressure is there in the atmosphere? We can measure it using this instrument called as barometer. So that should be clear. So here we have technically like completed the chapter, but there are a few important things which I would like you guys to know. Okay, now, and then we'll be doing some questions. Aisha, have you answered all of the questions?
Yes, sir.
You have? Okay. I'm providing some more questions to you. Okay, now, just give me a minute, guys. Give me a minute, and then we are going to continue. Okay. Meanwhile, you guys have a look at this diagram here, and you guys tell me this thing that what happens like if you were to like what is the reason why the boats float? What is the reason for the boats to float? Hmm? Answer the simple question to me that why do we get to see that needle will be a needle that is made up of steel or iron, it will sink in the water, but a boat made out of steel will not float. Yes. What could be the reason for this? You guys getting my question? My question was that why does a needle sink in the water, which is made up of steel or iron, but at the same time we get to see that boat which will be made up of steel and aluminum will not be sinking in the water, which is also made up of a metal. What could be the reason behind this? Yes. What do you guys think of this?
Sir, I'm not sure.
Okay. What about you, Vaika? Miss Vaika, you there?
Yes, I'm there. I don't get it.
Not getting it. Okay, let me help you. See, basically the thing is that whenever something goes into the water now, whenever something is there in the water, let me just share question to Aisha and then we're going to get you. Guys, just hold on for a minute. Okay, now. Yes, Aisha, I have shared some questions to you. Okay, now. Try to answer it before the class ends. Okay.
Okay, sir.
Also, the answer for the previous questions which you have answered, the example, rhizobium and lactobacillus used in fermentation, while harmful microorganism can cause food poisoning. Okay, microorganisms can convert nitrogen into nitrates, and the nitrates are the absorbable compounds which the plants can take up. Okay, na? Okay, good. So far, your answers have been correct. But the nitrogen fixation, that one you could have explained a little bit more. Anyways, okay. Guys, let us learn about upthrust or buoyant force. Okay. Basically, the water or any given liquid will be exerting a force in the upward direction. In the upward direction of pressure, a force is exerted by them. That is called as upthrust or basically buoyant force. So this is caused by pressure difference between the top and bottom of the object here. I mean to say that the pressure at the bottom of object is greater than at the top, because of which there is a net resultant force that acts in the upper direction. We can understand the buoyant force with an example. Take for example, you take a glass of water like this, hold the glass of water in this manner, okay, and try to sink it in a tumbler of water or in a bucket of water. You try to push the glass of water in this manner, in the downward direction. So will there be any resistance from the water? Will you see any upward movement? Will you be seeing that there will be an upward force on the glass of water, on this empty glass?
Yes, sir.
Yeah, I have taken a glass of water. This is empty. I just taken a glass here, empty glass, and I am trying to push it in a bucket filled with water. So I might feel some resistance. You might feel that the water is also trying to push it in the upward direction. While I'm trying to push it in the downward direction, water is also exerting an upward force on it. So that upward force exerted by any given fluid like water, or in fact gas also, that is known as upthrust or buoyant force. And it is because of this the boat will be floating. So due to the weight of the boat, it is applying a force on the downward direction. It is just let me put it on charge. It is applying a force on the downward direction, while the water is also applying a force on the upward direction. So if the weight of the force applied by the weight of the boat or the buoyant force, if they are equal, the boat will be floating. In the first situation, if their magnitude is equal, then the boat will be floating. Getting it, guys?
Yeah.
So the reason why the boats float, the first situation is that if the buoyant force, which is basically the upward force, or here also called as upthrust, if it is more than the weight of the boat, then the boat is going to float. Getting it, Viger? Then the boat is going to float.
Yes, sir.
In second situation, if the buoyant force is equal to the weight of the boat, there also the boat will be floating. Boat will be floating. Now let us say that if there are too many passengers on this boat, there's a capacity of, let's say, only 3, but it is filled with, let us say, 10 passengers. Then what is going to happen? Why does the boat sink?
There is too much weight, or
Because
the
of the
buoyant
weight.
force is.
Yeah. So there what is happening? The force exerted by the weight of the boat will be more as compared to the buoyant force. So there,
Yes, sir.
buoyant force is less as compared to the weight of the boat. The force exerted by the weight of boat is more, and the boat is now going to sink. So understood this principle now, how the boats float, how they sink.
Yes, sir.
Okay. Do we have enough time left? Okay, but we still haven't answered the question why needle will sink while the boat will float. What is the reason for that? The obvious reason behind that is that the needle is denser than water, while if we were to look at the case of the boat, it will be having a hollow design. If we were to look at the boat of the design of the boat, it is having a hollow design. Furthermore, it will be having a less density. Its average density is less than water, thereby it floats. So the density of the needle in comparison to water will be more as compared to the density of the boat. Furthermore, boat also we know that needle, when it, like whenever we put our hand or something into the water, some of the water is displaced now. Some of the water is displaced. You get to see the rise in the level of water. Getting it? The first factor for the first reason is that density. When an object floats or sinks, its density is compared to the liquid it is in. Okay, now? So if the density of the floating object is less, then the object will be floating. If the density of this boat were to be less than the density of water, it is going to float. But if it is more, then it will sink. Right now. So the reason why needle actually sinks is that the needle has got a higher density. It has higher density as compared to the water. That is why it will be sinking. While the boat, it does not sink because it has less density. Okay, now it is designed in such a manner that is hollow, and it will be displacing less amount of water. That's why it does not sink. Okay, now. So that's it for today. We'll be continuing from the next class. By the way, Aisha, let me just check your answers. For question number A, we have answered insect. And you have lactobacillus, fermentation, tuberculosis, rhizobium, and the last one you have answered. Okay, you haven't answered it yet. Tuberculosis. Okay, for the second last one you have answered. That is tuberculosis, right? Okay, Ramesh, you have this chapter, microorganism, friends and foe.
We have
You
we
have
completed the lesson.
Okay, that has been completed in the school.
Yeah.
Okay. So Aisha, one more is left to be answered. Which of the following organism can live without oxygen? So we have aerobic bacteria, anaerobic bacteria, fungi, and protozoa. You guys tell me this question. Which microorganism can live without oxygen? Is it aerobic bacteria, anaerobic bacteria, fungi, or protozoa?
Anaerobic bacteria.
Yes, Aisha, your answer is also correct. Okay, and that is anaerobic bacteria. Okay, now they actually do respiration without the oxygen also. Okay, now. Okay. The process of preserving milk by others can leave. I'm just checking the answers of Aisha. Okay, now others, if they wish, they can leave. Okay.
Bye, sir.
Okay, sir.
Yes, bye.
Thank you, sir.
Yes, you're welcome. For this one, Aisha, what you have answered, the process of preserving milk by heating it to kill harmful bacteria is called, that is pasteurization. Good. Previous one was correct. And then you have fermentation and lactobacillus. The process fermentation into alcohol using this, that is fermentation. Good. And here we have your answer, lactobacillus. Yes, Aisha, well done. Okay, now you have done good. Okay, Aisha.
Okay, thank you, sir.
Yes, you're welcome. Allah Hafiz.
Love is.
Yes, Suleiman, how are you? Your voice is not coming.